Okay, so this section is all about triangles, the area of a triangle. And in this first example, we're actually going to work backwards. So all three of your checkpoints, I said, here's the base, here's the height, find the area. This is working backwards. So it says, from the given area, find the height of the triangle. I recommend that you always start with the formula. And that's for all of the problems, because that's going to kind of visually walk you through the problem on what to plug in where. Okay? They tell us that the area is 36, so I'll put that in for the area. And then we have a base and height. Remember, a base and height always make a right angle. And this extension here is just showing you the height. Okay? The actual base is still just 8. So we have 1/2 times 8 times h for the height, because we don't know what the height is. That's what we're finding in this problem. So to solve for h, I'm just going to take half of 8. So we have 4h. And then to solve, we're just going to divide, and we get h equals 9. 9 what? Centimeters. Why is it not centimeters squared? Okay. Okay. Hang on. We don't have centimeters squared because it's not an area. If it does not say a equals, then it's not squared. From the given area, find the base of the triangle. So again, we are working backwards. The area this time is 22. We have 1/2 times base times height, which is 4. The height is given inside of the triangle this time. That's all multiplication over there, so I can take half of 4, even though the b is between them, it doesn't matter. Half of 4 is 2. And if you divide both sides by 2, you get the base is 11 feet. Questions on that? Okay, as a side note, what if I had something like, I don't know, 10 equals 1/2 times 3 times h. How would I do that problem? Isn't 3 really just over 1? Yes, and how do you multiply fractions? Straight across. So we get 10 equals 1 times 3 is 3, 2 times 1 is 2, h. Now, how do we get h by itself? I think I heard it. We're not going to divide here. What are we going to do instead? Multiply by the reciprocal. That's right. Okay, so here we would multiply by the reciprocal, which is 2 over 3. The reason why we do that is because the 2 and the 3's cancel, and you just have h left. Again, 10 is over 1, and you multiply fractions straight across, so 2 times 10 is 20. 3 times 1 is 3. So you'd have a height of 20 over 3, which is approximately, which is 18 2/3 if you made it into a mixed number. Okay? So the process is exactly the same if it doesn't divide evenly, but you'll solve it a little bit differently. Okay? All right. Find the area of the polygon. So the whole entire polygon. This is where we're going to find 2 areas, and we're going to add them together. Okay? So at the bottom here we have a what? Rectangle, and the area formula for a rectangle is length times width. So 7 times 4 is 28. And then we need to find the area of the triangle. Now, if this base is 7, this is also 7. So the area of the triangle, 1/2, base times height, is just 1/2 times 7 times 4 Again, I'm going to work with the numbers that are going to divide evenly or multiply nicely. Half of 4 is 2 times 7 is 14. So the area of the triangle is 14. The area of the entire polygon is just 28 plus 14. So what do we get? 42 meters squared, because it's an area. Questions on that one? Is that over there? Okay, last one, number 4. Find the scale factor of similar triangles PQR to XYZ. Then find the ratio of their perimeter and area. Okay, so what letter do we use for scale factor? Kind of like we use M for slope. K, right? Okay, K equals what? What is the ratio between the sides? Now notice that it says PQR to XYZ, so be careful of your order. How do we find the scale factor, or the ratio between the sides? What is that? Huh? You're thinking right, but we just want a ratio, which is, because a proportion is 2 ratios set equal to each other. So we just want that one fraction. So what is it going to be? Huh? Ratio between the sides. Come on, guys. Okay, I hear 6 over 10 and 3 over 5, but be careful there. We want to compare the triangles. We want to compare PQR to XYZ in one fraction. You guys tested over this already. Okay, how'd you get it? Okay, so you did 5 over 10, which reduces to 1/2. This is your scale factor. If you used the 3 and the 6, you would have gotten the same thing, as long as you pick sides that correspond. Okay? That is the ratio between the sides. What do we know about the ratio between the perimeters? That's right, it's the same, so the ratio between the perimeters is also 1/2. And what do we know about the ratio between the areas? What did we find out in that video? What's the rule? What do we have to do? Close. Ratio between the areas. We're not square rooting, we are squaring them, right? So we're going to have a squared over b squared. And those are just variables. So if the ratio of the sides is 1/2, we're going to have 1 squared over 2 squared. Well, 1 squared is just 1 times 1. And 2 squared is 4. So the ratio of the areas is 1/4. So the sides and perimeter are the same, and area is squared. Kind of like if you find the length of a side, it's just units. If you find perimeter, it's just units. But if you find area, it's units squared. So kind of the same deal there. Okay? Any questions?